Hello all, today we are solving LeetCode problem number 1582, special positions in a binary matrix. So we are given a matrix m cross n, which is a binary matrix named mat. Return the number of special positions in mat. So a position ij is called a special position if mat of ij is equal to 1 and all the other elements in the row of I and j are 0. So which means also they have given the row and column or 0 index, which means if we are looking at the example 1, this will be 0, the index means 0th row and first row and second row. Similarly 0 column, first column and second column. So if this position of ij is called a special position if there exists a value which is mat of ij is equal to 1 and the row I should have only 1% within it and column of j column j should also have 1% within the column. So if you're considering this first example, when you're looking at this particular position, this mat of ij has value as 1 and this row has only 1 as the value, remaining every values are 0, and this particular column also has only 1 as the value, only 1% within the column. There is other elements or zeros. So it is due to that reason this particular position is called a special position. So when you consider this one, you can see that in this particular column you have presence of another one here, so this is not possible. Similarly, from looking at this one as well, you have the presence of other one here, and it is due to that reason this is being removed. This is being not considered as a special position. So how do we solve the problem? So first approach which I am thinking of is to track the ones present in the row and column. So you will use a map to track it down based on the index, the 0 indexed column and row. So you have, based on the first example, you have 0 and you have 1 and 2. So these are the rows and these are the columns. So you fill in how many number of 1% within it as the value here. So you have the rows as the key and column as the key, and the number of ones present within the row and column as the value. So when you are at this position, when you are filling up here at this position, you encounter 1, and this is at the 0th row and 0th column, so you add 1 here. Oops, this is this position which is 1 1 and 1 here. So now you move here, it is 0, again 0 and 0 0 0. So at column 2 and row 1, so row 1 you have 1 here and column 2 you have 1 here. So now next you are encountering one more 1 here which is present in the column 0 and row 2. So you increment this by 1. Oops, this is column, I'm so sorry about this. Okay, so you increment this by 1 which becomes 2, and similarly this is in second row, so you increment, you add 1 here. So now you have filled the row and column value. Again iterate through the matrix. So when you iterate, you have to check 3 conditions, which is first one is matrix of ij is equal to 1 and row of I is equal to 1 and column of j is equal to 1. If these condition and so all these condition is true, then in that case what we have to do is we can increment the count. We can say that that is a special position. So you can increment the count by 1. So this is how you find the number of special positions within the matrix and you return. So with this idea, let us go ahead and code this up. We start with n is equal to length of this will be the row. Yeah, so n will be length of matrix mat, and m will be equal to len of mat of 0. So you get both these, and now rows is equal to default dict integer, and similarly column also default dict, and the default value is integer. So for I in range, now we are going to fill the rows and columns based on the occurrence of 1. So in range n, and for j in range m. So now if mat of I and j equals to 1, so in that case you are adding, row of I will be incremented by 1 because you found 1 there, so you are incrementing in the map the row of I value by 1. So row of I by 1, increment by 1, and the column of j incrementing by 1 as well. So now that you are filling the rows and columns using this loop, now the next task is to check if the row and column has any occurrence of 1. If there is nothing, then you will increment the result, and that is how you calculate the special positions in this matrix. So now for I again in range of n, and for j in range of m, and now if matrix of I and j is equal to 1, and again you have to check row of I is equal to 1 and column of j is equal to 1, because that will indicate that the one is present in one single row. In the row and in the column, if you are checking for occurrence of 1, there is only one occurrence exist. So it is due to that reason you will increment the result by 1. So row of I is equal to 1, and column of j is equal to 1. So in this case, result plus or equal to 1. So now you will return result, and there you go. We can run it. Rows, this I can reduce to row. I can change to row, it's not reducing, I'm sorry. Let us submit this, and there you go. Thank you.